This is the second part of 1.4, so I'll label it 1.4b. And it's just considering the exponential functions and the limits that we're dealing with. And you should be familiar with these limits from pre-calculus. We just have to write it differently. As you recall from pre-calculus, these values are important because if you remember, if the base is smaller than 1, then typically that would be a decay function, but then you have to pay attention to the reflections, which I will cover with you shortly. Please also remember that this is your indicator for your horizontal asymptote at y equals -2. So this graph shows you that it's definitely a decay function, as I predicted, with a horizontal asymptote at -2. So why do we care? Well, this limit as x approaches -infinity is asking for the end behavior. As x goes infinitely to the left, this function is going infinitely up. So this is your infinity. Now, as a side note, because I've said it before, that is not a numerical value, so you can write does not exist. Be ready to go back and forth on that. Now, this next one has a definitive answer, and that's because as x goes infinitely to the right, there's definitely a y value that this graph is getting closer and closer to, and that's the horizontal asymptote of -2. So this one has to say -2. There's no other option there. Now this next picture, maybe I should change colors, is really the same thing. Now this time our base is larger than 1, indicating a growth, but again, pay attention to the reflections. This one does not have any reflections. So as you look at this graph, this is definitely a growth function, and the horizontal asymptote on purpose is still y equals -2. But now, because it's a growth function, as x goes infinitely to the left, -infinity, we're getting closer and closer to the horizontal asymptote of -2 here. And then same thing, just flipped it. As x goes to positive infinity, we're going infinitely to the right. The function is going infinitely up. So infinity, but again, be on the lookout for an option that says does not exist. Because it's not a number, some people will say just does not exist. I'm a big fan of stating the behavior though, if anybody's curious. So you might have been sitting there and saying, well, when would you know if you have a reflection? Is if you have a negative value here or here. Because there's only one negative, this is one reflection. Your base is smaller than 1, so this would have been decay, but with one reflection turns this into a growth function. And I hope all of our rules from pre-calc are coming back to you. Your horizontal asymptote at y equals -1 kind of gives you your clues, because eventually you won't have the graph in order to answer this. That's why we teach you this in pre-calculus. So our left end behavior, as x goes to -infinity, the function is going infinitely down. -infinity up below does not exist below it as well. And as x goes to positive infinity, because it's a growth function and it's below the x-axis, I should say below the horizontal asymptote, we're looking at y equals -1. Same thing with this one. Let me change colors. This time there are 2 reflections. So the base being less than 1 with 2 reflections is your clue that it's a decay function. Your horizontal still at y equals 2. And so looking at the graph, I think it's pretty clear that as x goes to -infinity, this function is getting closer and closer to 2. As x goes infinitely to the right, the function is going infinitely down. So that is your -infinity, or again, does not exist. So based off of what we just saw above, there's basically only 3 options for infinite limits. So we're only answering this based off the limit as x is going to positive or -infinity of whatever function we're talking about, you know, got to name your function, is going to equal one of three different things. It's either going to equal infinity, negative infinity. Now remember, each of these options might have a correct answer if does not exist, or the horizontal asymptote. Does that happen on every one of those problems that we looked at? It was one of these two, and then the horizontal asymptote. As a quick reminder for your rules, and it might actually be faster if I just share the answer key with you, and I'll walk you through it, but it's just faster to write it this way. We saw this in pre-calculus, so it should be familiar with you, that we could either have two ways of getting growth function. Is if the base is larger than 1, or the base is larger than 1 with 2 reflections, or if the base is smaller than 1 with exactly 1 reflection. Now that 1 reflection could be the negative in front, or it could be the negative at the end. And you'll see me when I do these problems, I'm actually going to graph them out. I need to visually see it to get the correct answer. So decay is just the opposite. We're just flipping things around. So if the base is smaller than 1, that's typically a decay function with 0 or 2 reflections. And if the base is larger than 1, it has to have exactly 1 reflection. Again, pause the video if I'm going too fast. Copy this down. These are your notes, whatever you need. So instead of me writing all that down, I'm just going to jump to these examples. I'll show you exactly how I would do this. So this base 2/3 is smaller than 1. So initially that's telling me that that's a decay function. But then I'm looking at the negative right here, that's a reflection. Now where's the reflection? That's important, is over the y-axis. Now I didn't really give you where the y-axis is. The y-axis would look something like this. So as we reflect that over the y-axis, it would actually look something like this. Now this -2 would shift the graph down 2, but that actually doesn't matter here because they're asking for the right-hand limit. The limit as x goes to positive infinity. This graph is going infinitely up. And all that other stuff that they have in the problem will not affect this answer. Again, you might see does not exist as an option. So I'm trying to stay consistent with my explanations. So moving on to the next one. If that base is smaller than 1, which it is, typically that graph would be a downwards. But now that I'm seeing a negative in front, that's reflected over the x-axis. So it looks something like this. And this -4 would shift it down 4, which actually does not affect my answer because it's asking for the left-hand behavior. As x goes to negative infinity, the function is going infinitely down. So say negative infinity, again, does not exist, is an option. Here's another base that's smaller than 1. So I just have to work it out where we do. I just show that. This time it has 2 reflections. So it's reflected over the x-axis and over the y-axis. So maybe I should graph. I'm looking at this one right here, but it is shifted up 3. So the graph looks something more like this. So what's my actual answer? Is x goes to positive infinity, that's infinitely to the right. It is going infinitely down, so my actual answer here is negative infinity. That does not exist. Okay, moving forward with the next one. Again, you look at the base first. This base is larger than 1. By the way, we do the exponent before the negative in front. So we do have 2 negatives though, but as I draw this out, I would say, okay, it's a growth function. Negative reflects it over the x-axis. That's what this negative does. This negative reflects over the y-axis. So we're looking at this type of function, but it is shifted up 2. So like up 2 is your horizontal asymptote. This is a very lame picture, by the way. This is not a perfect graph, but all I need to know is the end behavior. As x goes to positive infinity, it's getting closer and closer to the horizontal asymptote. So this answer is 2. So moving on to the next one, you should know E is about 2.72, I believe it is. But anyway, the base is larger than 1 with 1 reflection. So the exponential function typically looks like this. The negative right here reflects over the y-axis, so it looks something like this. It is shifted up 2, but we actually don't care about that. We're asking as x goes to negative infinity, this function is going up. So this answer is infinity, or does not exist. And let's change colors again. Our base is smaller than 1. That's a decay function, except the negative in front reflects over the x-axis. And I'll just go ahead and do both steps at once. Reflect over the x-axis and shift it down 4 units. So that's where your horizontal asymptote is. And we're asking for the positive end behavior. Infinitely to the right is getting closer and closer to -4. So as we get to the last 2 examples, just don't forget some of the things we've learned. Notice that we threw a wrench at you, that we stopped asking for infinite behaviors. So what's one of the tools in our shed to help us is direct substitution. That's what this is. Please don't forget, as we learn new things, the old things. That if you can, go ahead and plug in 3 in for x plus 2. And just simplify a little bit. I'm not asking for everything. So just e to the negative first power plus 2. This is acceptable. If it's a multiple choice test, you might see the answer written like this, 1 over e plus 2. There's another way to simplify this, but that's good enough. Same thing with the next one, though. It's direct substitution. So we're looking at 1/2, plug in -2 here. So positive 2 minus 3 is to the -1 power, and then plus 3. Now this one's definitely doable because the negative exponent just means the reciprocal. So it's 2 plus 3, which should give you an answer of 5.